Okay. The first four, all you're doing is calculating the logarithms. So these logarithms are just asking you a question. Number one is asking 5 to what power equals 625. So you can do that in your calculator, figure out what number that needs to be. It is 4. Number 2, 2 to what power equals 1/8. So if you have a whole number and you're raising it to a power and you end up with a fraction, that means your exponent will be negative. In this case, it is -3. Number 3, 10 to what power equals 1,000? If you're raising 10 to a power, you can figure out what that exponent is by looking at the number of zeros in your answer. 3 zeros means your exponent is 3. Number 4, 27 to what power equals 3? You're raising a number to a power and you end up with a smaller whole number, not a fraction like in number 2, just a smaller whole number. That means your exponent will be a fraction. In this case, 1/3.
I can do that. I don't know.
Numbers 5 through 8, you are converting between exponential and log form. You don't have to solve anything. Number 5, this is in exponential form, which means we're putting it into log form. So the first thing you should write is log. Then you can use the loop trick if you need to. Start at the base, which is 3, draw a counterclockwise loop around to the exponent. And that's the order that you'll write these in the logarithm. So log base 3 of s equals t. Number 6, this is in log form. So we're putting it in exponential form, which means we don't need log. We can use the loop trick again by starting at the base, drawing counterclockwise. So this is a to the c power equals b. Number 7, log base h of 12 equals k. And number 8, 5 to the x power equals w. Questions about those first 8? Okay. Starting with number 9, you're using the properties of logarithms to solve the equations. You need to show your work, but you only have to check your answers if you get more than one answer. And that should only be on number 11. So on number 9, we have a logarithm on one side of the equal sign with just a number on the other side. To get rid of the logarithm here, we need to change to exponential form. So the same thing that we just did in numbers 6 and 8, change this to exponential form. So that's 3 squared equals 2x minus 1. Now we can solve for x. So add 1 to both sides. 3 squared is 9 plus 1 is 10 equals 2x. Divide both sides by 2 to get x by itself. So we get x equals 5. We only got one answer, so we do not have to check on this one. Okay, let's look at number 10. Number 10, we have a logarithm on both sides of the equal sign. So as long as they have the same base, we can leave the logarithms off and set x plus 5 equal to 4x minus 1. From here, we just need to solve for x. There are multiple ways that you could move things around in order to get x by itself. If you did it differently than me, it's not necessarily wrong. So don't start erasing if I do something different than what you did. Wait until you see what the answer is and then decide if you made a mistake. So I'm going to subtract x from both sides. I'm also going to add 1 to both sides in the same step. So that gives me 6 equals 3x. Now I just have to divide both sides by 3 to get x by itself. So we get x equals 2. Okay, number 11. We have 2 logarithms being added together. Anytime you have more than one logarithm on one side of an equal sign, combining those logarithms is going to be your first step. So to combine these 2 logarithms into one, log base 4 will stay the same. And since the logarithms are being added, that means we're going to multiply x times x plus 6. Now we have a logarithm on one side with just a number on the other side, which is how we started number 9. So when we have a logarithm on one side with just a number on the other, we change to exponential form. So 4 squared equals, let's go ahead and multiply x times x plus 6. To do that, we'll distribute the x and get x squared plus 6x. If you have x squared plus 6x, or an x squared and an x term, that should tell you that you're going to have to factor to find your answers. In order to factor, we need everything on the same side of the equal sign. 4 squared is the same as 16, so I'm going to subtract 16 from both sides. So 0 equals x squared plus 6x minus 16. And I'll go ahead and tell you this. The semester test will be in the exact same format as the review, even down to the fact that number 11 will be the problem that you will have to factor on. The numbers may be slightly different, but the method that you use on each problem will be the same. Like the method that we used on number 10 here, that's the same method you'll have to use on number 10 on the test. So on number 11 on the test, that will be the one where you have to factor. So to factor here, we've got 2 sets of parentheses. We know that x goes on the front part of both sets of parentheses. Then we're looking for 2 numbers that multiply to be negative 16 and add to be 6. If you have trouble coming up with those numbers, make a list of factors. So numbers that multiply to be 16, 1 and 16, 2 and 8, 4 and 4. Now we can look at each pair of factors to see which ones we can use to add together to get 6. We should be able to use 2 and 8. One of them has to be negative so that they'll multiply together to be negative 16, but we need them to add to be positive 6, so this should be plus 8 minus 2. Okay, these are not your answers. These are your factors. So if x plus 8 is one of our factors, that means x equals negative 8 is one of our answers. Same number, but change the sign. So if x minus 2 is one of our factors, x equals positive 2 is one of our answers. Okay, so since we have more than one answer for X, we need to go back and check. So when you go back and check these answers, you need to go back to the very first line of the problem and plug in these values for X. So let's try -8 first. So before you continue checking, you need to be looking at these numbers to make sure they're not negative. You can't have a negative number inside of a logarithm. So because we have a -8 here, and this also ends up being -2. We can't have that, which means -8 is not going to be one of our solutions. So we can mark out that as a possible solution. You can't have a negative number inside or in this position of a logarithm. So if we try X equals 2, so we're plugging in 2 for X into the very first line of the problem. We have a +2, 2 plus 6 is a +8, so we don't have any negative numbers to worry about, which means we can continue checking. The first couple steps in our check will look exactly like when we solved. So combine these two logarithms into one. Log base 4 of 2 times 2 plus 6 equals 2. Then change to exponential form. So 4 squared equals 2 times 2 plus 6, which is 8. You don't have to do the distribution the way that we did it when we were solving. We only did it that way when we were solving because we don't know what X is. So we had to do it that way. Let's do it a little simpler here. We can go ahead and add 2 plus 6 to get 8. And then we just need to check to make sure these values are in fact equal. 4 squared is 16. 2 times 8 is 16. They are equal, which means X equals 2 is a solution. Number 12. So on number 12, we again have two logarithms on the same side of the equal sign. You want to combine those before you do anything else. So when we combine two logarithms, the base stays the same. And on number 11, the two logarithms were being added, so we multiplied. Now the two logarithms are being subtracted, which means we divide. 91 divided by X. Now we have a logarithm on both sides of the equal sign. So just like in number 10, as long as they have the same base, we can leave them off. So we'll just set 91 over X equal to 13. Okay, so now we just need to solve for X. We need to get rid of the fraction. To get rid of any fraction, you're going to multiply both sides by the denominator. So the X's will cancel and leave us with 91. 13 times X is 13X. Then we just need to divide both sides by 13 to get X by itself. 91 divided by 13 is 7, so X equals 7. Questions on numbers 9 through 12? All right, let's look at a network diagram. So we've got bus routes that run between 4 large cities. Obviously, the arrows indicate the direction the buses travel. Number 13 says, how many ways can you travel from St. Louis to Chicago? Justify your answer. So you can justify your answer by drawing on the diagram, by listing out the different ways you can go. It doesn't have to be like you explaining what you did. You can just show me what you did. So here's what I did. I said you can go straight from St. Louis to Chicago. So I just abbreviated St. Louis to Chicago. That's one thing you can do. You could go from St. Louis to Indianapolis to Chicago. That's another way you could do it. You could go from St. Louis to Milwaukee to Chicago. Or you could go from St. Louis to Indianapolis to Milwaukee, then to Chicago. So in total, there are 4 ways.
I agree.
So number 14 says a travel agent is concerned that the diagram isn't correct. What about these bus routes seems suspicious? So my answers are, after you leave St. Louis, you can't get back. There's no routes going into St. Louis. Also, once you get into Chicago, you cannot leave because there are no routes going out of Chicago. Those are the 2 things I noticed. Did anybody else notice anything different than those 2 things?
One way to leave Milwaukee and straight into that one.
Sure.
Really a triangle.
Yeah, that's a good thing. I mean, that's a good one to say. If you want to leave Milwaukee, you have to go through Chicago. And once you're in Chicago, you can't leave. So
You just have to go to Chicago.
yeah.
You have no choice.
That's definitely a tourist thing.
I don't want to stay in Chicago.
Okay. Upon inspection, the bus company realized there was an error in printing the map. An updated network diagram is shown below. Arrows on both ends of an edge indicate the buses travel in both directions. So number 15, create a matrix R to represent the bus routes in this new diagram. So the cities are labeled with numbers now for the sake of making this matrix. So the first row of your matrix should be 0, 0, 1, 1. Your second row should be 1, 0, 1, 1. Your third row, 1, 0, 0, 1. And your fourth row, 1, 1, 0, 0. Number 16, how many ways can you reasonably travel from Chicago to Milwaukee and justify your answer? So reasonably means you're not traveling back to Chicago for a second time before going to Milwaukee. So like, you're not going to go back and forth between Chicago and St. Louis 4 times before then going to Milwaukee. That's not reasonable. So how many ways can you reasonably travel? So again, justify your answer by drawing on the diagram, showing me that you used the matrix, or just listing out the routes. I'll do a couple of those. That way you can see what that might look like. So you can go from Chicago to Milwaukee, so 4 to 1. If you use the matrix to represent that route, that would be R4, 1, and that number is 1. Okay, if you're thinking just without looking at the diagram, if you're thinking of the different ways you could go, you might think of going from 4 to 3 to 1.
Do we have to drop the numbers? I kind of just wrote like a word.
Yeah, that's fine. Any way you want to justify your answer. Okay, so this will be represented by R43 times R31. So if we use the numbers in the matrix, that would be 0 times 1, which equals 0. So again, if I'm just listing out these routes without looking at the map, this would be one that I would list, but it turns out being 0 because we know that there's not a route from Chicago to Indianapolis. So that number in the matrix is 0. So I understand that that's pointless, but that was part of my thought process. So I wanted to show you.
So the end is 1.
No, well, I'm not done yet. Can I finish or? I just said that. Okay, my next one would be 4 to 2 to 1. So if you're going to use the matrix, that would be R42 times R21, which is 1 times 1, which is 1. We could go 4 to 2 to 3 to 1. Using the matrix would be R42 times R23 times R31. That is 1 times 1 times 1, which is 1. Okay, so in my thought process, like I said, I used 4 to 3 to 1, but I ended up finding out that there's not a route from 4 to 3. So here, my next one would have been, I would have gone 4 to 3 to 2 to 1. I would have switched these two inside numbers. But since I already found out by my previous work that you can't go from 4 to 3, I'm not even going to write that one. Okay, so if we add up our total, there is a total of 3 ways you can reasonably travel from Chicago to Milwaukee. So, like I said, however you can show me and justify your answer is fine.
All right, do the next.
Last page. Finding inverse functions. You will use the same 4 steps on all of these problems. Change function notation to y, switch the x and the y, solve for y, change back to inverse function notation. Okay, so on number 17, y equals negative x minus 5 over 3. Then we switch the x and the y. So x equals negative y minus 5 over 3. Then we need to solve for y, which is what's going to look different about each one of these problems. So I need to first get rid of the fraction. We get rid of a fraction by multiplying both sides by the denominator. So we get 3x equals negative y minus 5. These 3's cancel. So that first step should be the same for all of us. After that, there are different ways that you could get y by itself, like different orders of things.
If you are in Mr. Paul's Scholar Academy group this afternoon, you will meet with Mr. Paul Lutman in the math circle. If you are in Mr. Paul's Scholar Academy groups this afternoon, you will meet with Miss London in the math circle.
Okay, so I added 5 to both sides. That doesn't mean your next step has to be to add 5 to both sides. So don't freak out if you did something different than me. Okay, I'm gonna rewrite this up here. So I have negative y equals 3x plus 5. I don't want my y to be negative, so I'm going to divide both sides by negative 1. So I have y equals 3x plus 5 over negative 1. Now, there are going to be different ways that you could write this answer, but you for sure will need to change y to inverse function notation, so f inverse of x. So you could just leave it as this fraction. That's perfectly fine. Or you could go ahead and divide both of these things by negative 1, which is just going to change the sign of everything. So negative 3x minus 5. Either one of those is correct. Does anybody else have something different than these two and you want to know if it's right?
How did it get on mine?
Okay, number 18. So change function notation to y. and switch the X and the Y. Those two steps should be automatic. You do not have to, but what tends to happen if you skip the first one is that I see more mistakes made if you skip the first step. I'll just say that, but that is up to you. Okay, so now we want to get Y by itself. Again, there are different ways that you could go about this. I'm going to add 1 to both sides. So I get X plus 1 equals negative 1/5 Y. Then to get Y by itself, we need to divide both sides by negative 1/5. So that gets Y by itself. Y equals X plus 1 over negative 1/5. I'm going to show you different ways that you could have this written and it still be correct. We started with G of X. So our inverse function notation would be G inverse of X. And we could leave this as a fraction, X plus 1 over negative 1/5. Or you could go ahead and divide by negative 1/5. That would give us negative 5X minus 5. Or you could have G inverse of X equals negative 1 minus X over positive 1/5. Depending on which order you moved things around when you were solving for Y, you could have any one of these 3 equations. They are all correct. Does anybody have something different and you want to know if it's right? Okay. Number 19, Y equals 2X minus 1. Then X equals 2Y minus 1. Okay, solving for Y, I'm going to add 1 to both sides. And I want the Y by itself, so I'm going to divide both sides by 2. That gives me Y equals X plus 1 over 2. So H inverse of X, you could leave it as that fraction, X plus 1 over 2. You could go ahead and divide both things by 2. That would be 1/2 X plus 1/2, or X over 2 plus 1/2, either way. Or you could have negative 1 minus X over negative 2, or negative X minus 1, either way. Anybody have something different than these 3 things? You don't have to have all 3 of these, by the way, just to make sure you understand that. These are just 3 different ways you could have your answer written, and they are all correct. Okay, last one. Change function notation to Y. And switch the X and the Y. And now we want to solve for Y, so let's get rid of plus 2 by subtracting 2 from both sides. So X minus 2 equals Y cubed. We want to get rid of the exponent of 3 by taking the cube root of both sides. Because the cube root and the exponent of 3 cancel out. So we just have Y equals the cube root of X minus 2.
You done.
We're not done.
Well,
Change back to inverse function notation. So K inverse of X equals the cube root of X minus 2. Can't really think of a different way that you would have this written. So everyone's answer should look the same on this one.
We're done.